So I think some of you try. Very good. I like that what you are doing. So basically, you have in this way. This is just a warm up. What we did learn already. How to apply dot products. And remember, dot product have got definition. This is definition actually. This is definition, and this is a theorem that we can always prove that it's like that. Okay. So now find the projection vector of u bar. So you are given u. That means here I'm just gonna write here. This can be written as. Can you write this quickly? It is 6 and 8 vector in component form. That's a1 and a2. Did you write that? Did you get that part? Jocelyn, Natali, you call this as number a1. And what is this one? This can be written as in the component form 12 and 5, and that's like your. This is B1 and B2. So in the formula, this is like A1, B. So all you need to know is what is A1, B1. Is that okay? Make sense? So the projection of vector U bar or V bar. So basically, all what that means is there is a vector quickly. I will say 0 to 12. There is a vector. This is 12. Maybe this is 6 and 6, 8 will be 8 here. So you have two vectors. So you have two vectors. One is 12 to 5, and imagine this is just a 5. You don't have to draw this, okay? Don't draw. Just watch this. That's the vector. I'm repeating this. So maybe 12 and 5. That's the first vector, which is A1, B1, and then you are finding what is the other one is. The grid. So other one is 6 and 8. So this is 6, 8. So we want to know what is the projection vector. It means you're trying to draw a perpendicular here. You draw a perpendicular, and that's the vector. See, this is what we have. Our goal is to figure out this. What is this? And then the magnitude wise this is the magnitude of that vector actually. Magnitude, okay. So all you do is just find that magnitude, which is u bar. You do the dot product. So this answer is, let's write the answer. Were you able to try? So what are the numbers? So the top part, u dot. So if you get confused with that u dot b here, so I already have that. So u dot, that is, you're multiplying. What are you multiplying? A1 into B1, right? So what is A1, B1? Can you quickly tell me? What's A1 there? 6 times? That's all, so simple. So you just multiply this and this, right? So you just multiply, correct? A1, B1. So simple. A1 multiplied by. So that's like 6 times 12, 6 times 12. Now this, I don't want to get confused with dot. I'm stopping because this dot is separate. That's called dot products, not actual multiplication. So you have to be careful. So it is 6 multiply, you star to multiply to 12, and then you multiply the other one. This one multiply to this one, agree? Which is, what is that? 8 times 5, correct? And 6 times 12 is 72, I think, or 70, yeah, 72, 840. That's the thing. This is what you are going to put right up here. At the same time, you also need, what is that magnitude of the, we need to know how big is this, what's the magnitude of this one. So this also you need to know magnitude. Even though it is like the vector v bar, we need to know what is the magnitude of this. So another one more thing is this is needed. So this absolute value means you just have to take the square root of those two numbers. Remember this? So this is a v bar. I took v as b1, b2. So this is b1 square plus b2 square. Of course, it is a Pythagorean triplet. Remember, I always say, which are the good numbers? Those are 5, 12, and 13 always go together. And then also 8, 15, 17, they go together. And 3, 4, 5 go together. These are special kind of thing in the Pythagorean triplet. If you know 2 of them, you know the third one. Agree? Jocelyn? Friday today, right? Oh my God. Today is my day. Then I go back home. My wife can't stop me today. I'm just kidding. Okay. So this one, if I'm rushing with this, recording is going on. If you don't understand, please watch this, okay? So all you do is B1, where is B1? B1, 12 and 5. But 12 and 5, you already know the answer is has to be 13 because of Python from earlier classes. By default you should know, but not always it's going to be so easy. So it will be like you have to literally do the work, 12 square plus 5 blah blah blah, and whatever 144 plus 25, you get 169, and 169 is 33. It is correct. So 30. So you can, so so what did you get here is the magnitude of vector V is 30. So put it in the box. Make sense? And all you do is you put it in the denominator, so you put it down there. So your formula is right here. So U dot V. So this, you got this, oh sorry, not this, U dot V. I kind of made a slight mistake here, okay? So when you are doing this, you are adding this part. Watch this, such stupid thing I do, it's not a vector. When you do a dot product actually is just kind of I'm so sorry here. So no, it's not a vector, it's the magnitude. This is the magnitude, it is also the distance, and it is also the length. It's like a kind of a length, it's just number, scalar, I call it scalar, or real number. So all you do is 6 times 12 is 72, and you're adding, and I think that's the mistake I did. Got it? I'm so sorry about this. So A1 B1 plus A2 B2, and then you add, and then it's 72 plus 40, and how much is that? 112. Did I see that? Or actually that U dot V also is this part. It is U cosine theta times. See part the formula, you can always write U cosine and then the magnitude of the V. So it is like you're multiplying two distances. So you're multiplying the green one. So it's like a green multiplication. This part, the green, multiply the whole, the red one type of a thing. This is the red part. So the dot product is basically that distance times the big one. Got it? But in this, when you apply the formula, nobody cares about this stupid thing. You just think of, okay, all you do is just do the formula, and you only need to know what is the red distance. Okay, now the answer for U dot V is this one. See, this part goes right here. How much is that? 112. Agree? And the bottom part is what? Absolute. What is the magnitude of? It is 13, so it is 13 square. There's a 2 there, so 13 square. And then the vector V is, here it is. I'm going to write 12. Either you can write in the component form like this. And then 13 times 13, 169. So it is 1 over 169. So we kind of get some stupid number, like a kind of doesn't go, maybe this doesn't go. What I'm trying to say is, and then you divide it to both of them. So your final answer is 12 over 169, and 5 times 2 is 0, 5 1 5 6, and 560 divided by 169. I don't know what number, just write this, that's it, you're done. Or if you want to write in the vector form, like the linear form, it is 12 over 169i plus 560 over 169j. Got it? So that's it, you're done. So just to understand, okay, projection vector of z along this is, okay. So before I progress to the next part, okay, watch this. Did you get this? 100%? This high? Okay, so no, I want you to make sure we are on the same page. Quickly open your laptop first. Before I go to the three-dimensional vectors, representation of vector in 3D, I want you to get is it's not coming up. Something is happening on my screen. Okay, I don't know why. Um, Okay, this is the one. Can you copy this quickly on your notebook? Write down this. Okay. So this is about one more problem that I think I've forgotten about. Which one? Okay, yeah, I think this is the one. This is what we already did. Okay, so I'll just get the printer, okay? Just hold on. Okay, take this. So can you copy the two questions? So you have a paper where it does not have these questions. Can you put these questions on your paper? take this, Natali? Can you write those two questions? So there is a car on the driveway. Can you see that? There is a little steeper for the driveway is a little steeper like this. And I want you to copy this. Find the magnitude of the force required to prevent the car from rolling down. You can see the car, you just, if you keep it on like a neutral, like without anything really stopping, the car can crash, roll down, right? So they're asking you how much force is needed to, and the information given is a car is weighing about 3,000 pounds, parked on a driveway that is inclined, and there's an angle shown. So the figure that you have is beautiful, right? The one that I printed on, nobody said yes. It's big, right? You can see. This one looks stupid. You can't even see that. So what I did is I just zoomed in and tried to make it like a nice one. So what is our goal here is, can we figure out this to, how much should I put a force on it, magnitude of the force required to prevent the car from rolling. That means we have to stop. So what is that force we have to put? I want you to copy this question first and then I'll walk through. Within 3 minutes we should be done this. If you read, then just thumbs up. So towards the end, I want to show the three-dimensional vector 3D. So how to figure out what are the coordinates in 3D, like how we have x, y, and then we want to know what is x, y, z for the three-dimensional space. You missed you. Did you complete? Yes or no? Jocelyn, you can take a picture because I just want to move fast. What is this here? This is the one. So the car is already here. It's like zoomed in and nice. The questions are not printed. That's I forgot about this part. What are the two questions? Oh, I forgot to do that. Okay, now I'll make it zoom in. Messiah, did you copy the question? Yes or no? Nobody's saying yes. Is that okay? Valerie, you copied? Okay, just watch this before I forget. Now, if I go to your Google Classroom, can you open your laptop? I just want to show what is that. You have Saturday and Sunday so that you can really go through those videos that I posted. So you see, this is your class. And then I wanted to, so this is what I put modeling vectors in the resultant for this. This is one. And this is one more lecture on characteristic of vector. And today morning, what I did was, morning time I did this and I just put it right in front of you. So this was introduction to dot product, so 9.2 lesson. So this was what I did in the morning. If you check, let me post this. Okay, so morning time difference between scale. Oh, this is the one. So the formula, where the hell this formula come from? So there I'm trying to show that. So I'll just put this link for you in the Google Classroom. Share. And then I make this one. Material, okay. 9.2. I'll just write quick link, post the link here. And I want you to really see it. Can you able to see that 9.2? Can you check your Google Classroom and confirm, thumbs up that you can see 9.2? So this is about scalar product, scalar dot, dot product also, then it is also scalar projection and also vector projection. That's what we did, right? The formula that we use today, right now, remember this formula? I'm explaining where the heck the formula comes from. That was the goal of this thing, because the class is not possible to finish everything. Now we move on to what we did right now. Are you able to see? Yes or no? Can you refresh your page?
Yeah, I refreshed now.
Yeah. So see, the thing is, you have to take responsibility. Go home. Okay, let me see what is done. What we cannot do, I'm trying to make those videos to help. Now, when I go to this one, the car thing, right? So I'm gonna make it bigger now. See what I have. And okay, can you see? Can you write down the answer? We'll write the answer right here. The question is. Can you tell me what is the answer for this? So, Natali, watch it. Can you close your laptops now? Now you know what to do, right? Nobody say yes. Just watch this. This is the, can you see this car is inclined here? Just imagine this car was in this shape. If this is the horizontal, this is the road which is horizontal, and the car was parked like this. Watch this. The car was parked like this. Can you see? This is the. So there's the weight. What is the car puts force? So there is a force which the car puts on the driveway, and that is the W. Got it? The weight of the car is the whole 2,000. In this case, if this car, which was 3,000 pounds, did you say 3,000 pounds on your thing? I forgot. Yeah, it is 3,000, right? Did I say that? Did I miss that? Did you miss the question? Can you write this also? A car weighing 3,000. I think I missed that. I'm so sorry. So, as you write this, Valerie, can you read this question as you are writing also?
A car weighing 3,000 pounds is parked on a driveway that is inclined 15 degrees to the horizontal, as shown in figure 5.
Okay. So the goal here is, just imagine, if the car was not inclined, I mean the road is horizontal, then the weight, which is like a 3,000 pounds, 3,000 pounds, the weight will be straight away 3,000 pounds. Got it? So it kind of, there is a word, now this, there is a vector kind of going down, and there is a horizontal, there is nothing, see? So horizontal is like 0, it's just going downwards. So this vector is making a 90 degrees. Can you see this 90 degrees here? So what it means is, there's only, this vector is only one, there's no horizontal, it's only the vertical. But in this case, let me make it a little bigger now. See, this beautiful thing happening is the weight of the car is the same weight. Can you see? Watch this. So this is the weight of the car. So because it is inclined, the weight of the car gets divided, resolved into two parts. One is the horizontal. So this is the horizontal, and that's the vertical. So so this force, which is the force or the weight, I call it force or weight, so which is W. So in this case, it is going down W. So the vector, the actual magnitude is W, but it's going, the gravity is pulling down, but the car is, this force is divided into two parts. One force is, it takes the car on the downwards, and another force is it puts stress on the driveway. Can you see? Put stress means little weight on the road like this. So putting pressure on the road, and that is given by that V. Can you see? So there is a two parts. I want you to write this. So let's write down this force, the actual weight is divided horizontally as U bar and plus V bar. Is that okay? First part. So your question is, why is it like that? Is because you can see that you can make a 90 degrees. This part is 90 here. This is 90. but you can see there's a horizontal, the car rolls down, it's U bar. So can we find out what is that U bar? So the question, what is the question I forgot? Can you read the question, A?
A car weighing 3,000 pounds is parked on a driveway that is inclined 15 degrees to the horizontal.
And my first question is A.
Oh, the question, sorry. Find the magnitude of the force required to prevent the car from rolling down the driveway.
So can you see? This is the horizontal, correct? Do you see that horizontal making the car roll down, and it is 3,000. So we want to push it up, but then that one is the black vector that you see W bar. So it is the projection. Can you see? So the angle that is made. Oh, they give you 15 degrees. Do you see that 15 degrees here? So that means if this is 15 degrees, then if this is 15 degrees, what this angle becomes 75. Can you see there's a one more kind of a 90 degrees here, a small angle there. Can you see that's 75. So why it is 75 is because if this is 15, and when you drop this like that, this become like a 90 degrees. So this is 90 degrees. So 15 and 90. So the other one becomes how much? Are you with me? Can you see this part? What I'm trying to say? There is a triangle there. There's a triangle there. So I'm talking about this triangle. You can make that also if you want different colors. Okay. So the main thing is that's 75. Once you get that 75, I don't want you to get confused with this part. All we want is that thing is the projection. This vector has a projection, and that projection is always, remember the U cosine, remember that cosine, we use the same trick. So horizontal is always cosine, but the magnitude of this is, so U bar, so this part, so this magnitude, how much force means what magnitude is nothing but, so that W bar, so it is W bar. So it is W bar into cosine theta. So I'm just making the formula time, okay? That is the weight of the car, actual weight of the car, that means downward it is 3,000, what is that? 3,000, correct? And you're multiplying the cosine of, what is the angle there? This theta here? 75. Can you see, so simple? Now on your calculator, you can use your phone calculator if you want, because there's no time. Can you figure out what is that 3,000, what is this answer? So the magnitude. Quickly. Did you get the answer there? I want to make sure you guys get that answer. Do you get around 776 or something? Do you get 7? Confirm? Are you getting? 776. Okay, so this is actually it's the component. So remember, this is the projection of this vector, or the component of this vector along this one. So projection is nothing but the horizontal component, which is 776. Okay, so this is the force needed to prevent the car from. So what is this? It is the force needed to prevent the car from rolling down. That's it. So that my magnitude is the force much required. And the last part is the V is, I want you to write these words later on, not now. So another question they asked, what is the second is, find the magnitude of the force exerted by the driveway. Now remember the driveway, there's a little weight on the road, so that's the force. So how much is that magnitude? So we want to know the other red color, vertical. Now for this, you can directly use the way I was showing you. Okay, the V bar, so this part. The other one is the vertical is nothing but, it is the same thing like this, but sine of 75. You can use this directly, see? So that's because That's because I'm using the, and if you use this, if you use this, you can write the magnitude y, the hypotenuse time whatever the sine of that angle. It means, oh, I forgot. You may be thinking, what the hell is this? Where is this? Is red is here, but this also is the red one. Do you agree? Make sense? So instead of finding this, it's the same. There's a triangle here. Look at it. There's a triangle here. There's a triangle like this, which says, see. So there is a triangle here. This is 75, and all they're asking you is how much is this? This is the hypotenuse. This is the hypotenuse, right? All they're asking you, what is this? What is that part? And what is this part? Do you got it? So kind of lot of thinking here is this is the adjacent. So if you want to find adjacent is the hypotenuse times the cosine of the angle. That's it. Nobody say yes or no. This is like a trick directly. Or if it is the opposite, it is the hypotenuse times the sine of the angle. That's all it is. So a lot of mathematics there, and I think it is difficult sometimes like this because too much of maths. So some of them they say, okay, the college curriculum, what they say is okay. If that's 3000 cosine, they call this is the vertical. Can you write down this is the vertical? So you resolve horizontal and vertical component. So this is the. You have a big paper, right? Can you write that? This is the horizontal component. Component means the projection of this vector on that. That's the projection, other side. So instead of writing like this, you could also write, I'm just finishing, that instead of this, you can think of the other triangle. Remember, if that is 75, this is 15 degrees. And you want to know how much is this projection like that also is the adjacent kind of thing. So the adjacent means it is the hypotenuse times the cosine of 15. So that also, both answers should give you the correct. So this means this is 3000 times sine of 75. Use the calculator and see 3000 times the cosine 15. And both will give you the same answer. Make sense? So as I said, I have recorded this. Just go home and watch it again. At this time, if you are confused, suddenly from nowhere I'm talking about 15 degrees, right? So I want you to think that it's nothing but the other, if one of them is 75, this thing makes 90 degrees, so 75 plus 15 is 90. So kind of two ways of doing. One is you just find out this by directly the unit circle, we always say cosine sine, or you can think of vertical projection or other side. And you can use the calculator and we are done with that. Is that okay? I know I did that. So what I'm gonna do is next is I'm gonna make another video. This is about three-dimensional. Or you can click a photograph if you miss something. Just click on it and you can walk through. So before the bell rings, I just want to wind up this class. By evening, I'll just try to make a video on this. This is called three-dimensional geometry or three-dimensional vector calculus. So what this means is, I want you to watch this. Don't do nothing. As I wind up, do you see something nice? What is the difference between that grid and this grid? This grid we have x and y, right? This grid. X coordinate, y coordinate. I'm finishing. Watch please. That grid is what? X, y, x, y, x, y, x axis, y axis. What's the difference between here? You have, which I forgot to put. This is what? The x axis, that's the y axis, that's the z axis. It means you see how far this distance, then you see how far on the y axis, and you see how much is the height, and you get 3 points x, y, z. So I'm gonna make another video on this, so be in touch. And as I said, take responsibility to really get all the content. Okay? Thank you so much. Yeah. So I didn't give you any package as such, so hopefully you're just watching, getting those things, okay?